Hey, this is Dr. White, and I wanted to tell you about a super fun reaction that you can do at the beginning of your chemistry class. I call it the nail reaction. And you're going to take a nail, okay, it looks like this, all right, and you're going to react it with copper sulfate, which is this blue stuff in here, okay? You're going to mix it up, put it into solution, and when you do that, you're going to have a reaction between the nail and the copper. Now, what you're going to need for this reaction are 6 to 8.5 grams of copper sulfate pentahydrate, 2 to 3 nails. You're going to need some sort of a plastic or styrofoam cup to do the reaction in so it doesn't stain any glassware. And they're going to need some 50 milliliters of deionized water. This is what the reaction looks like. Now again, these have been sitting inside of the copper solution for a while now. This is what the nail looked like at the beginning. You can see how they've changed. You actually got a coating of the copper on the outside of the nail. Okay, so let's work up the data. So if you remember from the experiment that the mass of the cup was 2.04 grams. The mass of the cup plus the copper sulfate was 9.21 grams. The mass of the nails before the reaction was 8.44 grams. After the reaction, the new mass of the nails was 6.86 grams. And the mass of the cup plus the dry copper was 3.82 grams. So these are all the numbers that we are working with. So let's work out some of the factors that we need to figure out the ratio of copper produced to iron used up. Okay, so the first thing we need is the mass of the copper produced. Okay, so that's going to be the mass of the cup plus the dry copper, which is 3.82 grams, minus, this is for the copper, minus the original mass of the cup, which is 0.024 grams. Okay, if we do that subtraction, I think I can handle this in my head. 1.78 grams of copper. Okay, now let's go over here and do this for the iron, right? So that's going to be the, which is going to be 8.44 grams.
minus the mass of the nails after the reaction, which is going to be 6.86 grams. Okay, let's do a little bit of subtraction here. So 8. Okay, we'll have to borrow 1 from this to make it 3. Borrow 1 from this to make it 7. So 8 from 13 is 5. And you get 1.58 grams of iron used. Okay? Grams of copper here. Okay, now that we've got this settled, now we can actually figure out the moles of copper, right? Because copper and iron don't have the same mass. The particle of copper is higher in mass than iron. So if we want to compare the ratio of iron produced to copper produced to iron used up, we need to change it into moles, right? We need to start thinking about particles. So let's figure out the moles of copper. So let's start off with 1.78 grams of copper. Okay, I'm going to divide this by the molar mass. So per 1 mole of copper, there are 63.55 grams of copper. Plug this into the calculator. Gives us 0.0280 moles of copper produced. Okay? Now let's do the same thing for the iron. So the iron we used up, put a little division here, 1.58 grams of iron. If we want to convert that to moles, we've got to divide by the molar mass, right? So what I'm doing here is dimensional analysis. It's a very handy tool for solving these problems. The mass of iron is 58.85 grams per mole. Do some math. 0.0268 moles of iron used up. Okay? Now, if we want to get that ratio, we're going to take 0.0280 moles of copper, divide that by 0.0268 moles of iron, do some math, and we get pretty close to 1.04 coppers per iron. Okay? Now, that is really, really close to a ratio of 1 to 1. Okay? What does that mean? That means that for every iron that was reacted, we get 1 atom of copper. Okay? Now, we have a little bit more copper, okay, 1.04 grams or moles per 1 of iron, but that could just mean that our copper wasn't totally dry when we weighed it. There's a lot of factors that could have thrown off that mass in our experiment. So why did the reaction stop? Which reactant was used up and how do you know? Well, to answer this question, we really need to think about what reaction actually occurred, right? So the reaction that occurred was we had iron, right, and that was in the form of the nails, right? That was a solid, and reacted it with copper sulfate. We dissolved that in water, right? So that was aqueous. And that reacted to form solid copper, which we could see that was the red stuff that came at the end of our reaction. And then in the end we made it iron sulfate, right? And this actually dissolved into the water. And we ended up getting rid of this when we worked up the reaction. Okay? Now, the iron was in the form of a nail. And the copper sulfate was this blue solution. Copper we know is a red solid. And iron sulfate, this is a clear liquid, right? So why did the reaction stop? Well, if you noticed, At the end, there was no more blue color, right? So that would mean that we totally ran out of our copper 2 plus ion, right? Remember, it was the copper 2 plus ion that gives us that nice blue color. If there's no more left, that means that we ran out of the copper 2 plus. Now, if we run out of the copper 2 plus, then there's no more to react with the nail. So that explains why there were nails left over. Okay? Now, later on we can start talking about words to describe this, right? In this particular case, we would call the copper sulfate, that's called the limiting reactant. Whereas the iron, that would be the excess, right? Because there was iron left over by the end of the reaction, okay? Now, let's think about what's actually happening to the atoms, right? So if we cut out the sulfate and I get rid of it and I write out this equation, I get iron plus Cu2 plus is going to react to form Cu plus iron 2 plus, right? So what ended up happening here? Well, over the course of the reaction, you get the transfer of 2 electrons from the iron to the copper, right? So now the copper becomes a neutral species, and the iron that has lost 2 electrons becomes a positive 2 species, right? There's a lot of different names we can call this. You can call it single replacement. You can call it a redox reaction. You can call it electron transfer. If I can spell electron. Many different ways to call that reaction. Okay, here's an interesting question. What would happen to the ratio of copper to the iron if you placed more nails in the beaker? Well, the reaction is still going to be limited by the amount of copper sulfate, right? You have less copper sulfate than you do iron, right? So the answer is nothing, right? You'd still have the same ratio. If you let the reaction go for less time, it's still going to be the same ratio, because the less copper you make, the less iron you use up, right? It's still going to be a 1-to-1 ratio. And that's why the chemical equation is so important, right? That ratio is 1 to 1, and it's going to make 1 copper and 1 iron sulfate. That's what those coefficients mean in terms of the chemical equation. Now, last but not least, okay, we know that the accepted ratio of copper to iron atoms for this reaction would be 1 copper to 1 iron. Okay? Why would our experimental value be different from the accepted value? Okay? Now, we've already written the balanced equation for this, so I won't go over it here, but what are some reasons why we might have a different value? Well, if you had more than the ratio of 1 to 1 for copper and iron, let's say you had maybe too much copper. What would cause this result in your experiment? Well, remember, we did everything in water, and we had to leave the copper to dry, right? So if you had extra water, I don't know why I keep putting ends on things. If you had extra water, okay, maybe your sample was wet, that would lead to a perceived amount of copper that is too high, right? If you had impurities, okay, maybe you didn't get rid of all the iron, right? Remember, we talked about how iron actually oxidizes, and that's the orange stuff that you see that was kind of on the filter, right? That would lead to too much copper. Let's say your ratio is under 1. So you had too little copper. What would lead to that? Well, maybe you decanted off some copper, right? Maybe if you were decanting or filtering, you lost some of the particles of copper. So that would lead to an amount of copper that would be too little in a ratio that's under 1 to 1.